Okay, so that was this. We've just done an example with independent sources. Let's take a look at an example with dependent sources. Okay, so we've got the 6-volt source. We've got an 18-volt source. Both of those are independent. And then we've got a 0.25 Vx source, a dependent source, where Vx has been defined as the voltage across this 2 ohm resistor here. And we've been asked to find Vx using source transformation. So keep in mind, this is the Vx that we want. That's the thing we're looking for. So as we combine, as we transform the circuit, we're going to pay very close attention to, in fact, I might even like draw a ground here, or at least denote like this is, these are 2 ports, A and B, and we want to sort of transform the circuit around the points A, B, but keep it intact, or keep the AB port. We want to keep track of where that is because we want to find the voltage Vx. All right, so we'll continue to keep track of where that is as we go through. Let's take a look at the things we can do here. We have a 6-volt source in series with a 2 ohm resistor. And so we can transform that into a current source in parallel with, it's going to be a 2 ohm resistor. And so that's, remember, the current source is, if you're converting from voltage to current, you're using Ohm's law, take the voltage, divide it by the resistance, and you'll get the current value. So that's going to be 6 volts, the 6-volt source, Vs, divided by the 2 ohm resistor, which is 3 amps. Okay. Now we have a current source here, or we have a dependent current source here as well. Okay, and so when we are transforming from a current source to a voltage source, remember the voltage source's value is just found again using Ohm's law. That's Is times R. And what is that going to be? It's Is. This is a 0.25. The Is value is 0.25 Vx times 4 ohms, the 4 ohm resistor there. And so that's 4 times a quarter. 4 times 0.25 is just 1. So the value for Vs is just Vx. All right, so that is step 1. We'll take a look at the next part in the slide. So focus right now just on this. Here's step 1. After the first, this was 2 transformations. The 2 transformations we did just above. Okay, now be careful. Keep track of Vx. Okay. Now keep in mind that this value here, this is a Vx. That did not get labeled somehow, so we're labeling it there now. Oh, sorry. You know what? I meant to write this at the next step, the next stage. So what we're going to do now is notice that we're keeping track of that Vx port. So I'm actually going to do this with, let's see, I'm going to use some different colors here. I'm going to use this color blue. So let's say we were, calling this here. This would be A, and this would be B, and then maybe we've grounded right there, right? We're going to keep track of, we're going to use that ground as we go through the problem. And so now we're going to transform again. We're going to transform this whole thing here. But keep track of Vx. All right, so where Vx goes. Now Vx is measured between these points here, right? Okay, so we do have the 2 parallel 2, that's a 1 ohm resistor. So if you wanted to kind of just take a look at that, here you go, here's these 2 parallel 2. Anytime you have equivalent resistances in parallel, or equal resistance in parallel, it's just half the resistance. So let's go ahead then and transform. We're going from a current source to a voltage source. So that voltage source's value is Is times R. It's Req in this point, in this example. And so Is, the value is 3 amps. And the equivalent resistance of those 2 ohm resistors in parallel is 1 ohm. And so the value of the voltage source is 3 volts. That 3 volt source is right here. And here is the 1 ohm resistance. Okay, so, so that brings us to, that gets us to step 2. Okay, now that we're at step 2, we have we have a simple circuit with 1 loop. And what we're going to do is then keep track of our Vx. So here's, we're going to put this as ground. Here's plus and minus Vx. And here's port A, and this is port B, right? So now what we're going to do is in step 3, we're going to do a KVL on the loop. Now the current has already been labeled as going clockwise, so we'll go with that approach. So as let's say we started in the lower left-hand corner, and I'll erase these points here, and we start to move clockwise around this, we're going to get a plus 3 volts. We're going to get a minus 1 ohm times I, that's the drop across the 1 ohm resistor. We're going to get a minus 4 ohms times I, that's the drop across the 4 ohm resistor. We're going to get a minus Vx, that's the drop across that dependent source. And then we're going to get a minus 18 volts, that's the drop across the 18 volt source, is all equal to 0. So let's combine some terms here. We've got the plus 3 volt source. Minus 1I and minus 4I is a negative 5I. Minus Vx, now, so right now we have an equation with we have one equation with 2 unknowns. I is an unknown and Vx is an unknown. I'm actually going to write Vx in terms of I. So check this out. We have minus 5I. This is going to be what was minus Vx here. I'm going to replace that with if we do a KVL here, so here's 3 volts at this point. This is a minus 1 times I across that drop, right? Across the 1 ohm resistor. So this is 3 volts minus 1I gets us to Vx, the node Vx with respect to ground, right? I hope everybody sees that. So we're here at this point, 3 volts. We move across this resistor and we get to this node here. That node is 3 volts minus 1I. Because the drop across the 1 ohm resistor is just 1 times I. All right, so we've just taken Vx and now expressed it as a function of I. Okie doke. So, so we'll finish the equation. This is minus 18 volts, is all equal to 0. And now we'll combine all of this. It looks like I have a typo in my notes, maybe. I'm not sure. So this would be, so if we take the 3, it looks like I have a typo in my notes. Oh, no, no, never mind. No, sorry. Okay, so here's what's going to happen. We've got the let's do this in another color here. We've got the 3 volts canceling with the plus 3 volts and the minus 3 volts canceling there. And then we're going to group these together. We've got that's a minus negative 1I, so that becomes a plus 1I. Combine that with that negative 5I, and we're getting a minus 4I is equal to, and we're going to move this 18 volts over to the other side, so it becomes positive. So minus 4I is 18 volts, or rather I is equal to 18 over negative 4, or in other words, that's minus 4.5 amps. Or what you could say, since it came out negative, that's 4.5 amps counterclockwise. It's actually going the other direction. Okay, so now we are ready to find Vx. So we'll just go ahead and do that. Now that we have Vx, as we've just discussed, Vx by doing what I sometimes refer to as a mini KVL, because we're like walking along the circuit, but we don't do an entire loop. If we start at 3 volts, right, remembering that we've placed ground at point B to help us keep track of where what the node voltages are. The voltage at point A is Vx. That node relative to B is the same as the voltage Vx. So Vx is, as we just said, it's 3 volts minus 1 times I. We just found I. So it's 3 volts minus 1 times, now I as defined, now keep track of this. Why is it minus 1I? It's minus 1I because we said that the current was flowing in this direction, towards the right. And if it's flowing towards the right, then the polarity across the 1 ohm resistor is plus on the left and minus on the right, which means we're getting a drop of 1I, right? Well, when we solved it, turned out it was actually going the other direction. So if we're going to stick with that polarity, the way that we've labeled it, we have to put in the value for I as negative 4.5 amps. So this is minus 1 times a negative 4.5 amps. And then, that'll get you your answer, which is, that's 3 volts plus 4.5 amps is 7.5 amps, a plus 7.5 amps. Okay. Now, if that's confusing to you, because you're kind of doing this double negative thing, if you'd like to redraw the circuit, go for it. Why not? Just draw it on there and say, okay, well, we found the current and we found out that it's actually going this direction. That's I. And so if it's flowing from positive to negative voltage, then it's plus on the right and minus on the left. And there we see that if we write it that way, then Vx would be equal to 3 volts plus the drop across the 1 ohm resistor would be 1 times positive 4.5 amps, because we've drawn the direction of it is actually going counterclockwise, which still gets us the correct positive 7.5 amps total.